let's go ahead and start. So a few notes about logistics and whatnot. So we will be recording this webinar, and we will be posting it in a few days. We typically send out announcements once that recording is posted to those that have attended, so that you can share with your colleagues and anyone else you want to point to the presentation. And it will be on the ISC YouTube channel. So as I mentioned, we're going to be doing a Q&A session at the end. So as you have questions, please do enter those in the Q&A chat window, Q&A or chat panel, and we will be handling those at the end. So what are we going to talk about today? We're going to talk about cases where you might need more DHCP performance. We're going to talk about some of our previous performance tests, specifically with Kea. Wlodek's going to go into really good detail in terms of what our test setup is and has been, and what methodology we're using and what tools. Obviously, we're going to present some results that I'm pretty excited about, and then we'll talk about plans for future testing, and then we'll take any questions that you might have. I mentioned that we'll have some other engineers on for the Q&A. Tomek Mrgalski, you may know him as the IETF co-chair, longstanding co-chair for the DHC IETF working group. So we're excited to have him on the call. And then we also have Razvan, who has been with ISC, I want to say close to a little over a year now, and he has headed up some of the multi-threading efforts. So we have really great technical assets on the call. So please do ask questions as difficult as you would like to. That's my invitation for you to stump the engineers, so please do so. So when we talk about DHCP performance, in the majority of cases, we're not talking about something that needs to be highly performant, right? So if you're on a small campus or a small business, you know, DHCP just sort of does the work and does not need to be sort of highly performant. Now, there are exceptions to this, and this is what we'll talk about, and this is why we're attempting to make Kea more performant as well. In the little example we have here, you know, if you had 86,400 clients, you know, in general, in very general terms, this could require sort of a environment that would support 2 leases per second. So we're very, you know, in general, for most DHCP deployments, very low performance is required. If we go back a bit, like say 10 years, you know, ISC DHCP at that time was probably in the 40 to 50 leases per second range. And ISC DHCP, of course, has never been multi-threaded, so it was certainly constrained there. Fast forward, say 5 or 6 years, and to where we are now, ISC DHCP is sort of in the 400 to 500 leases per second range. Kea has performed much better than that, and we'll talk about that in the coming minutes. But generally speaking, you know, in most scenarios, we don't need very performant DHCP. So let's talk about when we do. The main case is, of course, ISPs, and I know we have several attendees that are from ISPs. So internet service providers are the ones who have these large amounts of clients that are dispersed and need really rapid lease per second performance. Generally, the one that we all dread and love, I guess, is the situation where you have a power outage of an area, and then all of those clients, you know, the power comes back on, and all of those clients are attempting to obtain leases as they're rebooting. The other example you can take is if you had a very large campus with lots and lots of clients. You know, if you think of the typical work day back when, you know, people actually went into the office and will again at some point in the future. But, you know, if you have folks coming in at around the same time per day, then often those clients will need to get lease information at a certain time. So you have these peak scenarios. The other cases you could run into are like, you know, the classic coffee shop where you have maybe not so many clients, but you have sort of unusually short lease times where you're recycling through addresses quite rapidly. So that can have an impact on performance. The other part is with one of the driving factors for Kea's development was there was desire to have lease information stored in database backends. And this is something that we did with Kea. And of course, when you do that, it does slow performance, generally speaking. So one of the items that we're focused on with the multi-threading is how do we improve that performance for the database backends? And you'll see some numbers there as we go through the presentation as well. So this effort for multi-threading that we've been doing, we started in the 1.7 development branch. If you don't know our versioning system, so 1.6 is the current stable version, and the even numbers are the ones that we feel like you are ready for you to use in production, while the odd numbers are, intended to be for development and testing purposes. But this multi-threading work we've been doing in 1.7, that work is partially complete in 1.7.6. We're still working on multi-threaded support for hooks, and we expect a lot of this work to be complete and ready to be released in our stable version of 1.8 sometime in the summer of this year. Yeah, so the majority of what we're going to talk about with the testing is sort of the multi-threading versus the single threading testing that we had been doing on Kea to this point. And with that, I will turn it over to Wlodek. Wlodek has been with ISC for, I believe he's in his 6th year, so we're very fortunate to have him come and give us some details on this testing. So he'll talk to you about his experience in Kea testing, and moving into the multi-threading testing and what our environments look like and what tools we've been making use of to do the testing. And with that, I'll hand it over to Wlodek.
Thank you, Eddy, for the introduction. Quick question, can you hear me?
Yes, loud and clear.
Perfect. So let me start with pointing out 2 KB articles we already published. One is about a Kea performance test for version 1.4 and 1.5. And those numbers there can't be directly compared with the numbers I would be presenting you today, because we used for those tests different hardware and completely different testing methodology. The bottom line is that memfile backend was much faster than database backend, just like Eddy said, and it's that situation we have also in current results. And the second article is about Kea performance optimization, and there are tips and tricks about what should you do when planning production network. This is important piece of knowledge when performance is as consideration is in your network. Our testing setup is the simplest we can get. We have just 2 Dell R340 servers running Kea, and third server for our traffic generator, all connected via a single dedicated VLAN, and all running default configuration, except one point. Both servers are, for MySQL, we made a slight change, which is InnoDB flash log commit value from 1 to 2 to make MySQL saving data to the disk in sets, not one by one. And beside that, everything is default. As I mentioned before, 2 Dell servers R340. Those are not supercomputer type of thing. It's just one processor with the 6 cores and SSD disks. We just didn't want to inflate results by running tests on super fast gear. And OS we used is Ubuntu 18.04. To mimic clients during our testing, we used our own traffic generator, Perf DHCP. It's also open source and it's included in Kea sources. To build it from Tarball, you would have to use another configure time option, and also it's included in packages that we are uploading to Cloudsmith. In RPM, Perf DHCP is in the main package, Kea, and in debs, Perf DHCP is in a separate package, Kea admin, and manual documentation is included to Kea administrator reference manual and also with the package itself. For all tests we executed, Kea is for Kea we used as simple configuration as is possible. It's just one subnet with one large pool. We used no host reservation, no client classifications, no options, no shared networks. All the functions enabled by default are still enabled in our tests. Lease lifetime is longer than test duration, so we don't have expired leases or reclamations during those tests. Every single time we start new tests, Kea starts fresh with a freshly rebuilt database, no logs, nothing. And also thread number that Kea starts can be configured, and this differ in the tests. I will talk about that a little bit later. And important thing is that databases are always local. It's on the same system that Kea is running, just to reduce latency between components. We mimic clients just with the 4 basic messages. For V4, it's Dora, and SAR for V6. We are not doing renewals, rebinds, releases. Every single client comes, ask for address just once. It's important because when a client comes second time, ask for the address for the second time, the path in Kea code is slightly different. It's shorter, so giving out assigning such an address for the second time is much faster. That would alter our test results, so we make sure that that situation never happens in our test. Also, Perf DHCP is generating messages without any extra options, just those essential to get the file bucket to get an address. And as you can see from configuration and traffic details, this is not, strictly speaking, real life scenario, and we know that those kind of scenarios are planned for the later time when we investigate more options and more configuration. For now, we just have the basic numbers. Okay, so in all those tests we executed, we made a couple assumptions. First of all, we measure top performance. Point of top performance for us is then when the Kea is dropping 2.5% of all incoming packets. And Perf DHCP is not able to distinguish dropped or late packet, so we are all getting them in one category of dropped packet, and everything that is every packet that the reply was sent back to the Perf DHCP later, 2 seconds or longer after initial packet was sent, is considered dropped. And we had 2 types of tests. Basic tests, when we calculate those top performance, and we executed it 9 times, removing top, highest, lowest result, and calculating average out of remaining 7 results. And those calculated rates were all later used to run longer tests and observing how Kea behaves second by second. How many packages it received, it sent. And why we chose that 2.5% drop rate. This is a sweet spot where Kea is slightly overwhelmed. It's dropping just 2.5%, and we are able to observe all the regularly occurring or cumulative problems. If we would use rate that didn't cause Kea to drop packets, we would probably never see those type of issues. And if we would flood the system with, for example, 2 or 3 times more than Kea can handle, we also would be very problematic to reveal such a cumulative irregularities, just because Kea would be flooded at the beginning of the test. And I spend a lot of time trying threshold of the 1%, 1.5%, and 2% drop rate, and it was really hard to get stability in the test results, because when you're sending 72,000 up to 72,000 packets per second, 1%, it's a really small number. A 2.5% drop, it's not much bigger, but it's easier to manage such tests. And also 2.5%, we think that it's actually acceptable drop rate, because that means just the real client will 2.5% of the real clients in real network will have to just resend solicits or discovers messages. Okay, so basic results we got from testing. Top 3 charts are for single threading Kea, and bottom charts for multi-threading. As you can see, we don't have results for HA in multi-threading. As Eddy said before, developers are still working on making hooks multi-threading works with multi-threading. It's not here yet. It will be on 7.8, I think. And yes, for single threading, we can see that memfile is 5 to 6 times faster than databases, and HA, even if it's using memfile, is considerably slower. than running single Kea instance. It's just because in HA setup, both Kea instances have to exchange messages waiting for each other. That takes quite a lot of time. I will not be going to the details how HA actually works. It's slower. For the multi-threading results, that's a rabbit hole of opportunities how to test it. All depends on the thread number Kea will start up and which we can configure. Our testing revealed that we got the best numbers for memfile for running 4 threads, for MySQL 12 threads, and for Postgres 6 threads. And we gain 190 to 350% over single threading Kea. We still don't know why Kea v6 memfile is much faster than v4. It's under investigation. And all those numbers here we used to run longer running tests to observe second by second what's going on with Kea. And smart summary. Yes, performance improved for my multi-threaded. It's from 190 to 350%. Thread numbers used is 4, 6, and 12 for different backends. Multi-threading, HA with multi-threading support will be in 178. And another subject here is hyperthreading, because we used a system with one processor with 6 cores, and hyperthreading boost up our thread limit to 12. And we expect that in high memory input-output application, hyperthreading can actually reduce performance. So testing whether disabled hyperthreading on our hardware are planned. We just didn't have time to do it yet. And for longer running tests, those two charts are comparing Kea v6 work with Postgres, and top chart is single threading, and bottom chart multi-threading. Except the fact that multi-threading is more than 3 times faster than single threading. You can see that on the bottom chart there are a lot of irregularities. The red line on the bottom chart is actually number of solicit dropped, and blue line is number of replies dropped. We think that this regularly occurring problem is because of the database writing the data to the disk, and during those time, performance of Kea is reduced. In single threading Kea, we didn't observe anything like that because our bottleneck in single threading Kea was the number of connections we could open to the databases, and it was just one. And going multi-threading, opening multiple connections, we moved that bottleneck from Kea to database. And one of the next steps will be tweaking and tuning databases configuration to make it even faster and more reliable. For the next set of results, for you comparison of three backends, Memfile, MySQL, and Postgres, all running through multi-threading version, multi-threading, and Kea V6. Top chart is Memfile. As you can see, there are no dips and regularly occurring problems. And MySQL, the middle chart, we can see the rising dips, that purple dips on the lower part of the chart, and it's growing until it's reached 100%. So when MySQL is actually writing data to the disk, at some point Kea stops responding, and those times when MySQL is writing data, it's very frequently, but short period of times. And Postgres is quite a different thing, because it's writing data much less frequently, and in those times, Kea still replies to the incoming packets. You just do it much more slow. So our observations from those longer running tests is that we managed to move our bottlenecks from Kea to the databases, and we aiming for investigating database tuning, but we didn't have time or manpower to do it for this test. Just wanted to share basic results, and also the types of pauses that we are getting from those two databases, MySQL and Postgres, are different, and effect on entire system can also be quite different. The other thing we observed is what happens when a Kea reaches high pool utilization level. And one of the tests revealed, when we ran out of the addresses, it's revealed that when pool utilization reached 96.5%, performance dropped significantly, and it stays at the same level until the pool is exhausted completely, and then stop responding because of DHCP v4 protocol major. And all those charts I've shown you are available on our interactive report. It's attached to KB article about those results, and also on our website. You can check it on yourself, click on zoom in, calculate the differences, observe what's going on. And those results also contains history of tests, and more details like delays of packets. And we are running those tests as a part of our continuous integration system, Jenkins. And there is a link to our current report. It's built when something is triggered to master branch. So don't expect the same charts every single time. No? It's the code is evolving. So, but bottom line is that those are available for you every time. Just go on our Jenkins site and check it by yourself. And our future testing plan is to have basically more real-life scenarios. Add host reservation, client classification, change number of subnets, number of pools, how the huge number of subnets affect performance, experimenting with database tuning, also hyperthreading effect that I mentioned before, and avalanche scenarios that Eddy mentioned. What happened, how long it will take to start the entire campus after power outage. Basically, more realistic test scenarios. For now, just basic numbers. And we strongly encourage you to test performance on your own setup, using the machines you will be using in production networks to make it easier. We also attached to KB article all the configuration files we used and perf DHCP commands corresponding to all those files. That should be helpful. And if you would have any questions, just don't hesitate. Just ask from my Kea mailing list. And I think that's the end of my part. If you have questions.
All right, thank you very much, Wlodek. That was great. Let me see if I can pull up the QA part. Unfortunately,
just a second. Oh.
Yeah, unfortunately, the QA is not showing up for me. Vicky or anyone else on the call, is it showing up for you?
Sure. You just have to look under the answered questions, or I can just go ahead. So the first question was from Ryder asking, did you try connection pools? And Tomek has already answered this online. He said, yes, Kea now has a connection pool. We tried several different approaches, but it seems that the connection pool size equal to the number of threads works best. In other words, when you configure Kea to use 8 threads, it will create 8 threads and 8 connections, 1 for each thread. However, we're not sure if this is the final ratio. We're doing a lot of experiments. The multi-threading support is still a pretty recent thing. It's only been working for about a month. So let me just, well, I don't actually have to enable Tomek. You can unmute yourself if you want to add to that at all, Tomek.
No, that's pretty much sums it up.
So the next question, I'll just read the question and then Tomek, you may as well just answer it since you answered it online. From Stefan, is the mem file the limiting factor already or something else?
Okay, so memfile is our custom developed in-memory database, and we are using locking mechanism. So yes, this is the limiting factor. We are investigating a couple bottlenecks. And we understand that there's a huge area for improvement, especially the aspect that Wlodek mentioned, that the DHCP v6 performance is almost twice as fast as v4. There is no fundamental reason why it should be. The performance should be roughly the same. So we need to figure out what exactly is different, and we'll do our best to improve the v4 performance. But nevertheless, even the slowest case for DHCP v4 is 20,000 leases per second. So this is substantially faster than single-threaded Kea.
So we have another question from Martin. Does the database backend require transaction support? If not, in MySQL, MyISAM is a good alternative to NODB regarding performance. perhaps Tomek or Wlodek or Razvan, any of you could answer that. And I think we'll also encourage the rest of the folks on the webinar. You know, we are totally open to suggestions, other suggestions, especially as far as the database is concerned, because that's not really a specific area of expertise of ours. And it's something, you know, we've only recently really exposed the performance limitations on the database side. But anyway, so the question is about, does a database backend require transaction support?
Hello, everyone. Can you hear me?
Yeah, we
Yes.
hear you, Razvan.
Okay, so currently we have refactored some part of the code. So currently MySQL and Postgres don't use transactions when updating leases, but depending on your type of non-transactional database, you might actually need some kind of mechanism to have all the data be like so that is not overwritten by multiple threads at the same time. So you need some kind of consistency mechanism. Like in Cassandra, you have lightweight transactions, so they're not like transactions. So depending on your database, you might actually implement something that doesn't use transactions. We currently, MySQL and Postgres, don't use transactions because of the way we actually created the queries. So it actually depends.
Thanks, Razvan. Do we have any other questions? I think we've answered the ones that have come in, but we certainly have time for more if anyone wants to pose them to us.
There's another follow-up question from Ryder. Which ring buffer settings were used in the test? In my test, it has a big effect on the outcome.
Wlodek, would you be able to answer that one? You're on mute if you don't know.
Yeah, well, we use the default settings.
Okay, so we use default ring buffer settings. I'm not sure that answers your question. I know we're in touch, Ryder, so we may have some follow-up for you on that one.
So if anybody else has any other, you know, I expect that you folks on the webinar are probably all looking at Kea Performance, and that's why you were interested in that. So if you have any other suggestions other than changing the ring buffer size that you'd like to share with us, you know, we'd love to hear those as well. So you're welcome to put that in the Q&A or the chat. Otherwise, you see a bunch of links here on this last page. Wlodek was very interested in making sure that we published the full test results in the HTML. So that first link is an HTML page, and you can mouse over the test results and see more detail. Then the KB article that follows that, as he mentioned, has the configuration files as well as the test results linked at the very bottom. It's an attachment to the KB, so you have to scroll down to the bottom and you can download that.
Okay, I don't see any further questions coming in. Tomek has also pointed out that we have, you can see the settings that were used in our performance tests as well as the configs. And I think we'll be posting a link to that as well, but it's the the kb.isc.org docs Kea Performance Test 17-multithreading. And yeah, there's the link right there on the screen. Okay, good. So I think that wraps it up unless we have any additional questions. Oh, Ryder wanted to know about the number of clients that we typically tested with.
Okay, I tried to answer on the chat room, but we in all tests we aim to have more clients than leases. That will be assigned during all the during entire test. I think that it was more than 60 millions.
Oh wow, okay. We also have a question from Stefan. Have you had any experience with 40 gigabit interfaces or anything like that? Is there something special with this kind of high speed connection?
Okay, I can handle that. So we haven't done anything with 40 gig interfaces. Our understanding is that they absolutely are not needed. So we are talking about like the highest performance that we have is around 40,000 leases per second. So if you multiply this by 4, so this is 160,000 packets per second. So this is still 1 gigabit interface is more than enough. So I don't know, maybe with 40 gigabit interfaces, there's some trunking mechanisms that would interfere, but I don't think that we are in that range of throughput.
Okay, thanks, Tomek.
So I'm just going to throw in a question here. This is Vicky from ISC. This is really for the participants. I'm curious to know what level of performance you're looking for. Do you think, based on these numbers, that we have the performance that you need for your application? Do you have a specific target in mind? I'm just curious to hear about that. If anybody has any comments on that, you can just throw them in the chat.
Yeah, that's a great question, Vicky, for our purposes. That's something I would like to know as well. And if you don't have answers to that right off the top of your head, as you write out your requirements for your DHCP environments, we'd love to hear what lease per second range you're looking for. Okay, any other comments, Tomek or Razvan, or any additions? Okay, we have another one from another question from Stefan. With host reservation, the rate drops significantly, so more is better. Right now, we would be happy to see 10 times more than now. Okay, so this is sort of letting us know what you're looking for. So by 10 times more, are you saying before the multi-threading or 10 times with the multi-threading? Before, okay. Okay, good. Okay, so we have some more feedback. Martin, thank you for that. So currently we're doing 100 door a second with Kea 1.5. We will have to do 400 door a second in the future. Okay, that's good to know. Okay, so I think we, go ahead, Tomek.
There's one more question about memfile with RAM disk. Okay, we haven't tested this. So actually in Kea, there is a special mode that's in memfile that's called persistence. So we can turn this off. So it's not really realistic to reflect any normal operation, but you can tell Kea to do all the leases management entirely in memory. So there is no disk operation. It's crazy to consider deploying this in production, but it might be a good benchmark for efficiency of the allocation engine. So yeah, but since it doesn't have really real life application, we are not testing it.
Okay, thanks, Tomek. And I'm just trying to scroll back through to make sure we didn't miss any of the questions. We have some feedback that there's Hryder is seeing spikes in the thousands in outages, so 2,000 to 3,000 range of lease per second or door per second would be what we were looking for there. Okay, the others. Okay, so when you say one subnet with large pool used for testing, is it /8 subnet with large pool or something else? And Wlodek replies that we did a /8 for V4 and we used a /64 for V6. Okay, and with that, I think we've covered all of the questions. Someone please stop me if I've missed one, but I think we've covered them all. I really do appreciate everyone's participation. These were some really great questions, good feedback for us as a team to sort of guide in what ways we move forward. So thanks again for everyone for joining. I'd like to thank the ISC staff, Wlodek in particular, for putting this presentation together. And we hope to see you soon at another ISC webinar. So thanks again.